Hello everyone. So today I'm coming up with a very new video and a very informative video and one of the project which I recently analyzed and predicted some values. So here this is one more project, you can say machine learning project, wherein I will be doing a lot of analysis and I'm using some data set which will be used to train my machine learning model, and once I train it, I try to predict the values. Now here I chosen the example as a used car. So nowadays, the market is growing in that way, wherein the requirement of used car is more. So without wasting time, let us go for it. Try to analyze the data, try to see the data, and let us work on analyzing the data and predicting the values at the end. So now, before going into the program, how it is implemented, let us upload our data set. So as I said, I will be using uh, the used car data. Now to implement this project, I'm using Collaboratory. So again, I suggest the people who are working on machine learning, try to use Collaboratory. It will be a cheap way of, or you can say one of the cost effective, or you can say less cost tool wherein you can develop your ideas. So now let me upload my data. So here test data is there, training data is there. So I'll upload both. Okay. So both my test data set and training data set both getting uploaded. So you can see the test data here. If you want, you can use this one to see the data. So here you can see the data. So it has ID, maker, model, location, distance, owner type, manufacturer, age of the car, engine displacement, engine power, body type, VROM audit rating, transmission, door count, seat count, fuel type. Okay, so this is your test data. Now to train it, we have one more data set. It's a huge file. Let me download it. Let us see. So let me see the data. So it's very huge data. One thing here I can say, it is very difficult to open here. I'll try to open it and show you. Now you can see this training data. It has ID number, make, maker, model, location, distance, owner type, manufacturer, age of car, engine displacement, engine power, body type, VROM audit, transmission, door count, seat count, fuel type, price. Now this training data, wherein this data is collected, and we also have a price associated with each car. Now our aim is to analyze this data, try to correlate important can say factors which are affecting the price of the car. Once you know which all the things getting correlated, once you know the parameters, I'll give the name, actual technical name for it later. So you can predict the car price. Okay, so same thing, the price column is missing in your test data. So test data we will see later. Okay, so in test data you can see, I'll show the that also, test data also. Now you can see the test data wherein again we have a ID, we have a maker, model, location, distance, owner type, manufacturer type, age of car, engine displacement, engine power, body type, VRAM audit, transmission, door count, seat count, fuel type. But last column you can see we need to get a data or predict the data or predict the price of each car here. So we will use this test data at the end to get our price. So without wasting time, let us begin the analysis first, then implementation of, or you can say building a model. Once model is built, let us predict the value of each car. So let us begin our coding. Now important libraries are pandas, numpy, matplotlib, seaborn. Okay, so these are all initially we are importing. So let us run this code. So there are no error found. It is correct. Now let me move ahead. Let us include the data. Now I am using a car as a data wherein I am feeding the training data set to it. So wherever I use car, it will be like car data. Okay. So let us give that, already I given link. So you can copy that link from here. This is a training data set. So just click here. You can see here copy path. Just copy this one and paste it here. So I have already pasted. Just let run. So now the information is in car. Now you can check how many number of data or how much data is present in that Excel sheet. So just run it. You can see 53,515 data entries are there. Or you can say there are information about this much data. Next, how it is described. Okay, so you can see here what type it is, means float type. Just run it. You can see these are the data types. Okay, so information on data set. So what are the different information about that data set? Car.info. You can see. So ID is a int 64 type, and maker, model, object type. Distance is float type. Again you can see engine power is again a float type. So price is also float type. So very few parameters are there which are float type. Now let us look at each column name. Okay, as I already shown in the Excel sheet, you can see ID, maker, model, location, distance, owner type, manufacturer, fuel type, and price. So price tag is there in the training data set. So same thing is shown here. Okay. The next is the information about that one with reference to, you can make the view change also here. You can see. So minimum, what is the minimum value? What is 25% of it? What is 50% of it? What is 75? And what is the maximum value? You can see. So this is analysis. Again, just by typing this one, you can get it. Now head means first 5 rows will be available now. You can see 5 rows. 0 to 4. Okay, and information about them, it is there. Now if you use car dot tail, it will give the end 5 rows. Okay, end 5 rows. This is index value, you can see 53514. Okay, so these are the IDs and data. Next, here I'm checking any null values present in the data set. Okay, so you can see there are no null values, only in distance, engine power and body type you can find some null values. Okay, now let us go for visualization. One of the important factor of analyzing the data is visualization. Through visualization we can analyze it more better than the normal number. So let us begin that one. So I'm using cufflinks. Okay, now you see it will take some time to display values. Okay, if some values are unknown or you can say undeterminable, then there is a problem with the graph. Okay, same thing here. This is a heat map. So heat map, you can see body type. Okay, body type is giving more values here. Okay, then let us look at one more graph, heat map. Again, the body type. So there are no null values in a given data set, but it is saying. Now let us look at how many diesel cars are there, how many petrol cars information present in the data set. You can see 27,559, 25,956 are petrol cars. Okay. Now same thing is visualized here. You can see. So what happened here? Yes, now you can see the graph, which is representing number of petrol vehicles and number of diesel vehicles. So it seems some kind of here what we are doing through in visualization, we're trying to correlate. Okay, so let us see. Let us go further. Now here it is a engine power. So here kernel density we are looking at. So can we correlate this engine power count based on engine power? You can see. Now next is let us make a correlation between first owner, second owner, third owner, and fourth owner. You can see these are numbers which are saying first owner, second owner, and third owner, fourth owner. Okay. So same thing is again you can see they are all looks equal, almost equal to each other. So you can see same graphs again. So approximately all car owners types are same in number. Okay. Next, let us look at owner type with respect to price. Let us see. It will run for some time. Now you can see the box plot wherein owner type versus price has been drawn. So again, you can see from the plotting distribution rather than statistics, which will help in better understanding. The above plot shows that the median grades of the three groups, actually not age, it's now one more data here. So display. Again, we'll try to correlate fuel type and price. So you can see here. So fuel type and price, you can see the orange one, the fuel type, which is diesel, and here it is petrol. Now I think it is understood that the petrol type fuel car rates would be less and diesel type high. Then let us correlate all the values which are float type, okay, or integer type. So you can see there is a correlation here. So what type, how much correlated they are, it is showing here. Now let us encode the categorical variable using label encoder. So I'm encoding them. Okay. So now let us see encoded data. So this is the encoded data. You can see. So now using this one, you can even see the last 5 rows using the car.tail. Okay. Now with respect to price, let us correlate all the parameters. Okay. So now you can see from here engine power, manufacturer looks correlated. Let us do some dropping action here. Filter it out. Let us drop some parameters. Let us see what happens. Okay. So why we are dropping here? Because we see very lessly correlation between them. So we want to reduce our operation on them. To reduce that one, we are dropping it. Now let us find the most correlated. Okay. So price, engine power, you can see engine power, manufacturer, distance, engine displacement, body type, door count, seat count, and VRAM audit. So this shows the highest correlation between each parameters with respect to price. Okay. So here you can see most correlated here: engine power, manufacturer, distance. Few of them I can say. You can correlate all, okay, or few of them. Now here what so visualization actually takes a lot of time, and to execute that part of code, it really takes time here. So the practitioners can use the data and try to visualize all the things. Now here I'm showing one of them wherein I'm looking at body type versus price. Is there any correlation between them? So body type and its price, you can see this kind of visualization is there. Now let us train our model. Okay, so I'm using learning techniques here. Okay, sklearn. So first let us split data into our what is it? You can do this one, or you can skip, and you can separately train the data, and you have a separate test data which can be used to test it. Okay, so in both way we can do it. So after that you can evaluate your predictions. Okay. So let me first split the same data and work on it. Later I will show the other way also. So here it is a training data. Okay. Now let us apply the root mean square error and mean absolute error. I'm evaluating by both models. Okay. So medium here, medium values, then display baseline here. You can see the baseline for median, MEAE, and RMSE, root mean square error. You can see here. Okay. So you can use one of them, not every all, but one of them you can use. Now let us work on different models: linear regression, elastic net regression, random forest, extra tree, SVM, gradient boosted, baseline. Baseline, of course, you got the values here now, just now. Okay. So this is one way wherein the whole data set is divided into, or you can say split into some parts, some as a training data set and some as test data sets. Okay. So you can go in this way also. And by splitting and looking at the data, it is taking a lot of time. So you can work on those things and you can visualize the things. I'm using one more method here. To check the accuracy of the data models, or models, you can say models built. Let's wait for it. Now you can see the results evaluation by splitting the data from the same data set. So these are the things we got: linear regression, elastic regression, random forest, extra trace, SVM, gradient boosted, baseline. So these are all values we got from the MAE and RMSC. Okay. Now here you can see again comparatively different things and how much accuracy is there, that we need to see now. Okay. Accuracy. Let's look at that one. So as we see, both mean absolute error and model root mean squared, that is the baseline near SVM, which is performing the best in both cases. Okay. So the SVM is more nearer to the thing. Okay. Even linear regression is working fine, it seems. So let's look at that one. So this is with respect to SVM. I'll wait for it. Now let us, based on our analysis, okay, I'm applying now linear regression, okay, to predict the values. So training set I'm giving here and testing set I'm giving here. Both the paths you can find from here. Just click here, copy path and paste it here. Okay. So I'm using two factors, that is manufacturing here, engine displacement. So you can increase as much you want. Okay. So I'm using only two factors here. You can use multiple also, where you found the correlation. So let us look at the things. So now you found some values here. Okay. Now same thing, let us take that thing in the our test data set. So price is predicted now. So now let us look at the data using linear regression. This is using linear regression. So in test data you can find the result now. We have successfully found the price. You can see here price predictor using linear regression. You can see the same thing in the test data set. Okay, same test data set you can see here. Price predicted using linear regression. So even you can use one more method like SVM to predict the data. So let me run this also. So you can apply multiple, again I can say, algorithms models to predict the data. So this is SVM. We're using SVM to predict the data. You can see one more column will be added beside it. This is price predicted using linear regression. Okay. So one more column will be added once it finishes its execution. Let it run. So now through SVM also we have successfully predicted the values. Now let us put that value in our Excel sheet. So the column will be price predicted. Let us look at the data, whether it is reflected in the Excel sheet. So you can see here two columns as I told. So this is price predicted using linear regression. This is price predicted using SVM algorithm. So you can see
the linear regression is yielding somewhat good result than the SVM. So thank you for watching.